In this video, we're going to learn how to name covalent compounds, which are the opposite of ionic compounds, because covalent compounds do not contain anions or cations. This means that covalent compounds do not have any metals, because remember that metals lose electrons in order to become cations, and they also do not contain any polyatomic ions, because again, a polyatomic ion has charge overall. So because the elements within a covalent compound don't have charge, meaning that they don't gain or lose electrons, we say that each element in a covalent compound instead shares electrons with the other elements. So as a result of this, the naming is similar to that which we see of ionic compounds, but works just a little bit differently. So to start off, we're going to look at how to develop the scientific name of water, because H2O, we see that there is no metal and no polyatomic ion, which means that this compound is a covalent compound. So if you're not familiar, let's look up the names of chemical symbol H and chemical symbol O. We see that H is hydrogen and O is oxygen, and that's the first step that we can do by naming the first nonmetal, which would be hydrogen, and the second nonmetal, which is oxygen. So as usual, we can start by writing the first element in the compound, which would be hydrogen here, but then we need to make the same modification as in ionic compounds by removing the -gin, the suffix of the second nonmetal, which is oxygen in this case, and replacing it with the suffix IDE to indicate that it's part of a compound and not by itself. So replacing oxygen's suffix with IDE would mean the suffix would be oxide. Now, one difference that needs to happen in covalent compounds is that we need to add prefixes to one or both of the elements in order to show how many of each element exists. This is because it's actually possible to have multiple combinations of two different nonmetals that exist in different numbers, and we'll take a look at an extreme example of this later. Now, in order for us to do this, we need to actually know what the numerical prefixes are. The good news is you've already seen 3 of them. We remember from a previous video where we looked at weird polyatomic ions with hydrogen that the prefix for 1 is mono, the prefix for 2 is di, and the prefix for 3 is tri. Now, the rest of the numerical prefixes are very easy to remember if you are good at remembering the names of shapes. For example, the prefix for 4, tetra, a good example of where this prefix is used is in the word tetrahedron, referring to a 4-sided pyramid. The name of a 5-sided shape, you might know, is what we call a pentagon, and likewise the name of a 6-sided shape is what we call a hexagon. Then 7 is probably the hardest one to remember. The prefix for 7 is hepta, 8 would be octa, 9 would be nona, and 10 is deca. So in this case, to indicate that water has 2 hydrogens, we add the prefix di to indicate 2 hydrogens, and because there's only 1 oxygen, we can simply call it monoxide. We don't call it monooxide because we don't like to repeat vowels one after another in English. So there we go. The scientific name of water is dihydrogen monoxide. So you know, if anybody comes around with a petition asking to ban dihydrogen monoxide, you know that either they're trying to kill you because they're trying to make water illegal, or they're just playing a rather cruel joke on you. If we take a look at the next example here, we have CO2, which is a very important gas as far as climate change goes. So let's go ahead and look up the symbol for C. So we see element symbol C is carbon, which means that is our first nonmetal, and we have oxygen as our second nonmetal. We remove the suffix oxygen and replace it with IDE for oxide once again, but this time we don't need a prefix for carbon because we only have one. If you wanted to write monocarbon here, that would not be wrong, but generally, if you don't write anything here, it's understood that we only have one. One convention that you'll see is that we only use the prefix mono for the second element in a covalent compound, and I don't exactly know why this is, but simply put, the prefix mono is optional for the first element. Then we have two oxygens, which means that we need to add the prefix di. So CO2 is carbon dioxide, as we well know. Then if we take a look at this third example here, NF3, if we look up the names of N and F, we see that N is nitrogen and F is fluorine. So let's go ahead and write nitrogen here. Again, we can call this mononitrogen because there's only one, but if you don't write mono, that's also correct in this case. So we have three fluorines, so if we write the beginning of fluorine, remove the INE, the suffix, and replace with IDE, fluoride, and because we have three, we would add the prefix tri to indicate that we have three fluorines. Finally, we have an example where we actually need prefixes for both of the elements here. So B and Br, if we look those up on our periodic table, B, the chemical symbol for boron, and Br, the chemical symbol for bromine. So let's go ahead and write the name boron, and because we have two, we would add a di here, so diboron, and then just like with fluorine, with bromine, we write the element name without the suffix and replace the INE with IDE, bromide, and because there are four bromines here, we would add the prefix tetra to indicate that there's four. Now, to illustrate why numerical prefixes are necessary in covalent compounds but not ionic compounds, we can take a look at the extreme example where we have these 6 different compounds here, all of which, if we follow the name, remember that N is the chemical symbol for nitrogen, and then O is the chemical symbol for oxygen, and if we replace the suffix with IDE, we would end up with nitrogen oxide. Now, if we did not have the numerical prefixes for covalent compounds, then every single one of these compounds would also be called nitrogen oxide, and we would have no way of telling which one is which. So this is where the video is going to leave you. Your challenge is to see whether you can use your knowledge of numerical prefixes, keeping in mind that mono is only required for the second element, and see if you can identify the prefixes to use for each of these nitrogen oxide compounds. And when you're finished, there are ample practice examples that you can use, both where we take the name and write the chemical formula of a covalent compound, and vice versa, where we see, based on a formula, whether you can write the correct name for that covalent compound.